Hey, my name is Trey Cooper, and today we will be talking about stacks. So, stacks are a collection of elements, but the thing that makes a stack different is the way that the elements are retrieved from the collection. So, in regular collections, you are able to just pull out the element from by the index. So, whatever index you want to get, you just go ahead and get it out. But in a stack, it's a little different because the way that the elements are taken out are in a last in, first out order. So basically, when you put something in, the last thing that you put in the stack is the first thing that's coming out. So you can't just get an index. You get whatever was the last thing that was put in. So in to like visualize this for you, what how it will look is say you put your first element in the stack. My hand is the first element. And then you put another element in the stack. So this is element two. When you want to get out element one, you're gonna have to take out element two first and then take out element one. So whatever's on the top of the stack is what comes out first. So that's what we will be implementing today in Java. So let's go ahead and get into coding this up. So I'm going to start off by making a new class. I'm going to call this class stack. Import. Let's go ahead. Mark this. All right. So inside of this stack class, we're going to go ahead and create our internal array. So this array will not be accessible by anybody from the that's using this class. So if you're using the stack class, you won't even know that the array is there. But let's go ahead and set up these internals. So the first thing we're going to need to do is create our array. I'm going to do public object array. Now the reason I'm using object is because we want this class to be generic. So we want people to be able to put whatever elements they want into the array. So if they want to put a string in there, they can do it. If they want to put an integer in there, they can do it. So the way we'll do this is by declaring a parameterized generic type of t. So this is going to be whatever they choose. So if they want to choose a string or an integer or whatever, they can, or one of their own data types, they can do that using this t. So that's why I'm using object here, because as we know, all all data types originate from this object. They all inherit that object element. So once we have that done, we can go ahead and go create our pointer. The pointer is where we are on the stack. So when we add an element, the pointer will increment up one. So we will have an integer pointer. All right, once we get that, we can go ahead and create our constructor for this class. So we're going to do a public stack. We're going to take the size of the stack. So when you create the stack, you set the size for how large you want your stack to be. So once we do this, we can go ahead and initialize our array. I'm going to go a new object of size. There we go. And then we can initialize our pointer to a -1. The reason we're setting our pointer to -1 is because we want the pointer to indicate if the stack is empty. And this is how we will indicate if the stack is empty. If the pointer is -1, then the stack is empty. All right, from here, we can go ahead and begin coding our methods. So we're going to have 5 methods. The first method is the push method, which will allow you to put things onto the stack. The next method is the pop method, which will allow you to take things off of the stack. Then we will have a peek method, which allows you to look at what's on top of the stack without actually taking it off of the stack. And then we'll have an is empty method and a is full method. So these are what pretty much what they say. It checks if the stack is empty or if it checks if the stack is full. So let's go ahead and start off by implementing our push method. So push was going to take a t element. Remember, t is our parameterized type, so is whatever the user wants to use. And now we need to go ahead and first we need to check if the stack is full. If the stack is full, then we can't push this onto here. So we're going to have an exception that is thrown when this happens. So we're going to go if is full. We're going to utilize this method that we haven't created yet, but we will create the is full method later. So if this stack is full, then we're going to go ahead and throw a new stack full exception. So throw new stack full exception. And we're going to just have it say stack is full. All right. So there we go. We see this. This is going to check to see if the stack is full. If it's not full, then we can go ahead and proceed to pushing the element onto the stack. So we're going to take the element. We're going to go array. Oh, first we need to increment our pointer first, because remember our pointer is pointing to 0. And then whatever element is on is going to be pointing at that element. So we need to go ahead and increment it before we add. So pointer plus plus, increment our pointer. And now we can set the array at the pointer to be this element. All right, so that is our push method. Now we need to do our pop method, which is going to return a element of t. I'm going to call it pop, takes no parameters. Scroll. All right. So for this pop method, what we need to do is we need to do our check to see if it's empty. Because if this stack is empty, there's nothing to pop. And we can go ahead and throw a new stack empty exception. Now these exceptions don't exist. We have to create them. Stack is empty. So we will create these exceptions, but we will do that a little later. So let's go ahead and continue. So for the pop method, we need to, let me explain this before I type it out. So what we need to do is we need to get a temporary variable to hold the element that is at the top of the stack right now. And then once we do that, we need to set the element in the array to null. That way we can actually get it out of the stack. And then we need to decrement our pointer, because now the top of the stack should be pointing at the element that's below it in the indexing order. And then we can actually return the element that we popped using the temporary variable that we set up. So if that didn't make sense, let's go ahead and actually code it out so you can see what I'm talking about. So the first thing we need to do is set up a temporary variable that is going to hold our element that we want to pop. And we actually need to cast this to t. All right, so after this, we can go ahead and remove that element from the array by setting it to null. So this will set that index to null, which effectively removes that element from the array. And then from here, we can go ahead and decrement our pointer. And then we can return our temporary variable. All right, so what we're doing here is we're getting this placeholder to hold this variable so we can remove it out of the stack. And then we can decrement our pointer and then return that variable. So this effectively pops the element off the stacks and returns it to the user. Next, we will need our peek method. The peek method is very similar to the pop method, minus the fact that we are not going to actually pull the element off of the stack. So instead of setting up that, we can just return it. All right. So now we're just getting the element off the top of the stack if it's not empty. Next, we need to go ahead and create our isEmpty method. So it's going to return a Boolean. is empty. This is going to check to see if the stack is empty. So the way we're going to do that is just by returning if the pointer is equal to -1. Because remember, if the pointer is -1, that means our stack is empty. Public boolean, and this is going to be the is full method. So in the is full method, we're going to return if the pointer equals the size. No, not size. It's going to be the array dot length -1. All right, so we check to see if the pointer's at the end of the array. If it is, then we are full. If not, then we aren't full. All right, so this is it. Now we just need to go ahead and create our exception classes. So I'm going to go ahead, create a class, stack full exception, data structure. I'm going to put this in the exceptions package. Stack full exception. All right. It extends class exception. So we're good there. And now we're just going to add the constructors for this. So I'm just going to use the exception constructors that we already have. So I just import those, and I'm going to change this to say message. And there we go, stack full exception. And the reason you're getting this yellow is because it wants you to add a generated serial version ID. So do that. Also, let's create the stack empty exception. All right, so I'm going to extend exception. And then we can go ahead and do the same exact thing. Grab the correct constructors. All right, there we go. And then let me go ahead and do this so it can stop complaining at me. All right. Once that is done, you can save that and you can close these out. Import your exceptions. Oh yeah. And then don't forget to add your throws declarations. All right, so now we have our class complete. This is our stack class. And I have written some tests to run these through just to make sure that they are working correctly. So I'm going to just run these tests that I've created. They're simple tests. So now I just have some push tests, just pop tests. These tests are just going to check to make sure that these are working correctly. This is not a fully extensive test suite right here that I'm doing. This is just testing the basic functions and making sure that they are working. I will post these tests in the description, so you can go ahead and get those out of there, copy and paste them into your project, and you can run these tests and update them as you see fit. So I'm going to run these tests and make sure that our stack is working correctly. All right, as we can see here, we have all green and our stack is working fine. So if you enjoyed this video, like and subscribe and hit the notification bell if you want to see more content like this. Thank you for watching, and I will see you guys in the next video.